Hey everybody, welcome back. This is Find the Pair for the live performance exercises in Module 3. And same idea for this. We're not going to be recording or doing time, but I would highly suggest that you do. We're going to get started by opening up Rot 13, which is just going to let us rotate all of this obfuscated text. We'll go ahead and paste that in there. Now that we have a problem statement, let's go over to Replit. We'll scroll on down to the bottom, as we have been, or sign in. It might be a good idea if you've been signing in, because you'll probably be able to save some of these things. For our purposes, though, it's always good to, well, actually, I'm not really sure if it's always good to do anything, but we have been doing it this way, so we're going to keep doing it that way. Grab all of this. That's the obfuscated code. Okay, cool. So let's have a look at this. Given a list of, all right, we've got one thing. We're going to put a comment for multi-line comment. We're going to use asterisk and a forward slash and a forward slash and an asterisk to wrap it around. So given a list of non-negative integers and a target sum, find a pair of numbers that sums to the target sum. Variable pair is equal to call to find pair for sum. Looks like it's got an array of numbers, and we're being told that it's non-negative integers, and then some kind of a target sum. Then the return value from this function is going to be an array that contains the two numbers that add up to the sum. So a bunch of things should jump out. First would be the function we're going to write is called find pair for sum. The second thing that should jump out, well, let's not order them like that, but another thing that should jump out would be an array of integers. So we could say something like array, or we could say integers, and then maybe target sum, and then do the stuff. And now let's consider our test case. If we're returning an array from this function, then theoretically we're going to want to have a assert arrays equal function. Now you could absolutely get by with something else, but for our purposes it might be a good idea to go over how to write those just one more time. Assert arrays equal, it's going to take an actual, an expected, and a test name. And the reason we're going to go over this is because assert arrays equal is really not necessarily the most difficult assertion function, but it does require a little bit of thinking through it, as it were. So if we think through it, there are two things that we need to consider when comparing two arrays. One is same values, and one is same length. Same length is going to be rather simple. We're just going to compare the length of the actual array, and we're going to compare that directly with the expected length. So same values. Now same values is one of those where there's a bunch of different ways to do this. What we're going to do is we're going to assume that they have the same values. Then, and let's go ahead and move these kind of in a better order. So I'll put this one here, and then we're going to iterate over one of the arrays. It doesn't matter which, because we're sorting out the idea that the lengths might be different here. Variable I is equal to 0. I is going to need to be less than, let's say, expected.length. And the way this is going to work is we're going to assume that it's true. If it's not true, we're going to adjust our same length same values to be false. So I'll say if expected at I at any point is not equal to actual at I, then we know we no longer have the same values, and the same values should, of course, be set equal to false. We could probably break at this point, just because once we find out that the values are not the same, we don't really need to keep going. And then down here, we're going to do something like if same length and same values. And since these are both Boolean values, provided that they are both true, then this if statement is going to return true. Then we'll say console.log, and we're going to do the ES6 string interpolation version again, just because we've already seen a video where we did the non-string interpolation version. And this is where, well, I don't want to say my age is going to show, but I always have to do this rather carefully. So it's like failed, and then here we put in the value by that, failed, and that's the test name. And so we say, okay, so we got a square bracket there, expected, we got a space, and then our expected value, comma, but got actual. As you can see, once you get in the rhythm, that it's actually way easier to do than the string concatenation using the plus operators. Okay, so now that we have an assert arrays equal function, we want to make liberal use of this example here and maybe create one more example. Now you might notice that there are a lot of assumptions that need to be made here. One of them would be, hey, what do I do if I can't find a pair for the sum? And that's an excellent question. Since the problem doesn't tell us, we can do one of two things. We could assume that there will never be a case where the pair for the sum is not present, meaning there always will be two numbers that add up to the target sum. But that's not necessarily that great of an idea. So instead, let's go ahead and assume that we should assumption return an empty array in the event that the target sum is not producible. Oh wow, we're making this way too more complicated. In the event that the array doesn't contain what we want. There we go. That's a good way to get around how to spell that. So anyway, not spell, but just how to describe what our assumption is. Essentially, returning an empty array in the case where we don't have what the problem is asking for us, that's going to be enough. So if we do that, let's jump on down here and we'll say variable actual found is equal to find pair for sum, call it on this. Variable expected found, and what I mean by found is that this is going to be in the event that we have found two numbers that sum up to our target sum. So expected found is going to be, and it looks like they want those to be in the order that they appear in the array. But it also, that could be another assumption that we would check, which would be, hey, do I need them to be in the order that they appear in the original array? Variable test name found, well, that's a little bit much. So we'll just say assert arrays equal actual found, expected found, and should return an array of the two integers that sum to target. That's good enough to work with for now. Then we'll say actual found, would it be lost? Sure. Actual lost is equal to, we'll say actual not found. Find pair for sum. And for this one, let's go ahead and copy this, but then we'll just kind of chop it up a little bit after we get it in there. And so let's say that the target sum is 11, and we'll change one of these values to 1. We'll change this to 17. Let's make sure that none of them actually sum up to 11. Okay, good. And that's not really that attractive looking, so we'll move it over a little bit. Variable expected not found equals an empty array. And then our assert arrays equal function, or the call to our assert equal function, is going to have actual not found as the actual value, expected not found as the expected value, and we should return an empty array when sum cannot be made. There we go. That's a decent way to say it. So now that we have our tests in order, we are going to click run, and run at this point is going to ensure that our assertion function is set up correctly, that we've named the variables properly, and that things aren't misspelled or things are going wrong. What we're going to see back is something like failed, and then it'll tell us both test names, expected, the arrays that we told it to expect, but got undefined. Excellent. So now that we say cannot read property length of undefined, oh, right. That is what it's going to say. Essentially, we are unable to do what we had done previously because right here, if these are undefined, it'll kind of break right there. So, what should we do? Well, let's assume for a moment, actually, we'll just make this kind of easy. We'll say return an empty array. Perfect. Unfortunately, that's actually going to pass the second test, but as you can imagine, this is not that big of a problem, and from what we've seen so far, we can assert that the assertion function is written correctly. So now, let's jump into the problem and think about how we might accomplish this. First idea that we're going to visit is that we do not need this to be a hyper-efficient solution. It just needs to get the job done, and that's going to be what you keep in mind when you're practicing for the interview. Later on, you're going to learn that efficiency is key and that analysis of your function and description of such is something that's very important for an interview to get an actual job being a developer or an engineer. But for our purposes, we really are just looking to see if you can actually do stuff with the fundamental elements of JavaScript later on for all of that efficiency things. So what I would consider is that it's probably going to be the idea that we're going to take one of these and then check the sum with the rest of them. So I'm going to start with 3, and I'm going to check to see if it sums up to 9 with 34, 4, 12, 5, and 2. Then if none of those are the case, I'm going to move to 34. And what I'm going to say is our quick nod towards efficiency is that if I'm on 34, I don't need to check 3 again. Similarly, once I get done with 34, checking 4, 12, 5, and 2, discovering that none of them add up to 9 with 34, I don't really need to check 4 with either 3 or 34. So I'm essentially going to be moving along this array as I go, checking to see if any of them add up to 9 with any of the other values. So we'll say create an empty array, iterate over the integers, and then inside of here, this is where it gets a little bit, well, what we're going to do is the way that the inner loop is going to run is that we're going to iterate from current integer over rest of integers. And then in here, we're going to check, and we'll say outer. Wow, that's a really interpretive version. We'll say outer and inner, and that's just going to give us check outer value plus inner. If sum is target sum, then we will push outer and then inner to result array. And that's going to handle anything that we need to put into the array. So we'll say create a result array up here. The result array is empty, so if any of this doesn't happen after all of our iteration, we know we already have an empty array, so we're just going to return the result array no matter what happens. If we have a target sum, we assume that what we're doing here is going to catch it. If we don't, this will run to completion, and then we'll just return an empty array. So let's go ahead and start coding it. We'll say result, and maybe not result, let's say pair. Pair is equal to an empty array. Then at the end, we're going to return the pair. Iterating over the integers. We've already used I during our assertion function down here. That's not usually the kind of thing that's going to matter, but just in case, let's name this j. So we'll say j is equal to 0. J is going to need to remain less than the integers dot length, and then j++ is going to ensure that it increments by 1 each time. I'm going to wrap my curly braces around the pseudocode so that it's nice and easy to see. Iterate from the current integer over the rest of the integers. Now this one might not be obvious, but what we can do is we can say variable k is equal to j. That'll mean that whatever value j is at, that's where k will start. So when j is equal to 0, k is going to start at, well, let's think about it. Do we actually want it to start at 0? We probably don't. We essentially want k to start at j plus 1. That way, k is going to start here, and j will have started here. So j will start here, k will go from here to here. Then we'll move j up 1, which moves k up 1, and then I'll move from here to here. Now, I actually haven't done this in a while, so if I'm messing this up, we will figure out why we messed it up in a moment. But this is essentially the idea. And it speaks to one of the cool parts about for loops, which is why I focus so heavily on teaching y'all this early on, because later you learn about higher order functions and a bunch of other cool ways to do things in a much more rapid fashion. But a lot of times, if you know how to do things with for loops, you can do a little bit of messing with what the iteration would ordinarily cover, as opposed to having to iterate over everything or getting sort of complicated with the inner functions. And so, yeah, all of that. Anyway, k++ is going to increment k by 1. And okay, check outer value plus inner. So we'll say if outer value is going to be the value at j, and we could probably do that by making an alias for it, but let's not. We'll say integers at j plus integers at k is equal to target sum. Then we know that integers at j and integers at k are the two values that we want. And we messed up our curly braces because it auto-completes them for us, but that's okay. So we're going to pair.push integers at j. Oh boy. And then integers at k. And push is kind of cool like that. You can actually say integers j, comma, integers k, and it'll just one after another push everything that you said inside of there into pair. So I think that should be it. You figure when j gets all the way to the end, k is going to cease this for loop. So all of this won't happen for the value when j is equal to the last value. It'll only happen for the last when j is equal to the very second to last value. And again, we're kind of blending a lot of this, but it's like j isn't equal to the second to last value. It's equal to the index for the second to last value. But a lot of times, if you get used to this, it's okay to sort of blend those. So let's go over what we've done. Pair is equal to an empty array. We iterate over the integers. From there, we iterate inside of that iteration over the rest of the integers using k based on j. And then we're going to check to see if integers at j plus integers at k is equal to the target sum. If it is, we're going to push into our pair integers at j and then integers at k. After all of that is done, we're going to return pair. So we have our test set up. Now that we have the function working correctly, let's go ahead and hit run and see what we did wrong. And we're in great shape. You may want to take a moment after you completed a function like this to start messing with some of the inputs to see if it really does work, but for the most part, provided that you were able to get through this, you're going to be in good shape. So let's copy all of this and go back to do the superfluous part. And by superfluous, of course, I mean it's nice to kind of put the code in here and see that it submits properly, but as we've seen on a lot of the previous problems, you're not going to get any sort of like robust automated tests here. If we hit run, it's basically going to be like, hey, the student should create and run their own test in a separate replit, which we did. So we're in good shape. Thanks very much for watching this video. Hope you enjoyed it, and we'll see you in the next one.